This is from the AQA Chemistry Trilogy chemistry paper. It's the second foundation paper from 2018. The whole question is there to watch before we do the review, so pause as you go and see how you do for yourselves. So here is 1.1, 1.2, 1.3, 1.4, 1.5, and finally 1.6, and this is a 9-mark question in total. So for 1.1, you're being asked to complete this table. We're told how many protons and electrons there are in sulfur, and we know this from the periodic table and from the data above, because 16 is the atomic number, which is equal to the number of protons, and in an atom, the number of protons is equal to the number of electrons. To work out the number of neutrons, we have to do a very basic calculation. I've got a mass number of 32, that's protons plus neutrons, and I've got my atomic number, which I've just said is number of protons. So my neutrons is the difference between them. 32 take away 16, the correct answer is 16 neutrons. For 1.2, we're told sulfur is in group 6 of the periodic table. Complete the electronic structure of the sulfur atom represented in figure 2. So, again, we can go back to the information we had. Sulfur has got 16 electrons. To answer this question, you've got to remember how many electrons each shell can hold. The first can hold 2, second and third can hold 8 each. At GCSE, we don't go beyond 2 in fourth energy level. But if I've got 16, I've got 2 on the first shell, that means I'm going to fill the second shell with all 8 of them, and I've got 6 left. And again, a quick check that you can always do, sulfur is in group 6, that means it has 6 electrons on its outer shell. If you don't have 6 on there, it's gone wrong somewhere. Moving on to 1.3, sulfur reacts with oxygen to produce sulfur dioxide, and you're being asked for the word equation on this one. So sulfur plus oxygen, and then the key thing here is that we use the arrow to mean goes on to become, and sulfur dioxide is the product on the right hand side of that arrow. 1.4, what effect is caused by sulfur dioxide? This is a fact you need to remember. Sulfur dioxide causes acid rain, but you can also remember that non-metal oxides are acidic, just as you need to remember that metal oxides are basic. And if you remember that sulfur dioxide is acidic, it makes sense it's going to form acid rain. On to 1.5, figure 3 shows the mass of sulfur dioxide in the Earth's atmosphere from 1984 to 2014. And a student has said that the mass of sulfur dioxide decreased every year between 1984 and 2014. Is the student correct, and use data from figure 3 to justify your answer? Well, we're saying every year from 1984 to 2014, and it's clearly not the case. Because what we can see is that there was an increase from 1984 to 1987, and there was actually a constant value from 1987 to 1990. The decrease has continued from 1990 through to 2014, although you can see it's actually levelling off also at 2014. Finally, on question 1, we have 1.6. Figure 4 shows the percentage of sulfur dioxide released by human activities. We're told the value for electricity generation and transport. So what is left for industry? It's a straightforward percentage calculation. I've got 100%, 69 and 6 of that have been used up already. So we are left with 25% as our answer. And that takes us to the end of that question.